Welcome back. Today we're going to finish learning about covalent bonding. So this next example is a nitrogen bonded to a nitrogen. So we know that that's a diatomic molecule because it's two nitrogens bonded to each other. And since it's diatomic, we know that it's going to be nonpolar. We need to take a look at the periodic table. And we find out that nitrogen is over here in family 5. That means it has 5 valence electrons. And the number of bonds it needs to make is the same as its oxidation number. So it's going to need to make 3 bonds. Okay. And it's in family 5. It has 5 valence electrons. The nitrogen needs to make 3 bonds. Okay. And we filled in here that each atom needs to make one. We need one atom from the left and one from the right here because it is diatomic. So we need a total of 2 atoms. Okay. So sodium's nitrogen's dot diagram has 5 dots to represent its 5 valence electrons. And one we're going to bond it to also has 5 dots to represent its 5 valence electrons. We said we circled the smallest number of bonds, which in this case are both 3. So we're going to be using a triple bond when we make our model. So we take a look at the chart that was in the notes, and we find nitrogen here in family 5, and a triple bond down here. So both of these nitrogens have to bond this way. So that means this one has to have a triple bond. It's going to hook to this one, which has a triple bond also. And this kind of confirms our idea that we're going to have 2 nitrogens. So line drawing, it shows that these are triple bonded, which means there's 6 electrons here, 3 from the nitrogen on the left and 3 from the nitrogen on the right. And then to make the dot diagram of the molecule, we start off with the same element symbols. We look at the chart, triple bond, which is what we have, represents 6 electrons, 3 pairs, one electron from this nitrogen and one from this nitrogen in each pair. So we're going to go ahead and put the bond right in here. There's the 3 electrons from the nitrogen on the left, and 3 from the nitrogen on the right. And we complete the dot diagram. Okay. We can check. Each nitrogen now has 5. It's 5 valence electrons. I put these in blue, and I put these in blue, and these in black. If you look, there's 6 being shared plus 2 is 8. 6 being shared plus 2 is 8. The formula is going to be N2. All 3 of these diagrams have 2 N's. 1, 2, 1, 2, and then N2. The name of this compound is going to be di, and we never do anything to the name of the first element, so it's going to be dinitrogen. Okay, this last one says we're going to bond carbon and hydrogen. So we know that this is not diatomic, but it does happen to be polar. It's kind of an exception case. It's like the carbon dioxide, it's hydrocarbon. All these things that are hydrocarbon are non-polar. We need to find hydrogen and carbon on the periodic table. Here's carbon over in family 4, has 4 valence electrons, and here's hydrogen in family 1 with its 1 valence electron and oxidation number 1. So carbon's in family 4. It has 4 valence electrons, and it needs to make 4 bonds. 4 plus 4 is 8. Okay. Hydrogen is in family 1. It has 1 valence electron. It has an oxidation number of 1, so it needs to make 1 bond. So we're going to put the carbon with its dot diagram with 4 dots. The hydrogen's dot diagram has 1 dot. Okay. Now, when we think about these number of bonds, okay, first off, we want to circle the smallest number. So when we look at the diagram in the notes, we're only going to be using single bonds. Okay. And the other thing is, remember how we crisscross the oxidation numbers? Well, the number of bonds is the oxidation number. So we can move this 4 over here, and we can move this 1 down over here. Bonds down over here, and this 4 down over there. Okay. The other way we can think about it is by looking at this chart. And we see that we're going to be making single bonds. Hydrogen in family 7 makes single bonds like this. It has to look like that. Okay. And the carbon is over here. This is the way family 4 can bond. 4 single bonds, 2 singles and a double, or a single and a triple. Well, we're only going to be using single bonds because that's the only way hydrogen can hook to the carbon. It can only hook on with a single bond. So there's no place where way it could hook on here with this double bond. And there's no way it could hook onto this triple bond. It could hook over here on the sides with the single bonds, but then there'd be nothing to hook to this side. And remember, we have to have something connected everywhere. So this is the one that we have to use. Okay. So it's going to look like this. So we can really think to ourselves, it's going to take 4 hydrogens, 1 for each spot over here, to finish the line drawing. Okay. And like I said, we can crisscross the oxidation numbers. And to do that, we say we need 4 hydrogens and 1 oxygen. 1, 2, 3, 4. Each place to hook on. They're all hooking on with only single bonds. Okay, so to make our molecular drawing, we're going to start off with the carbon that we picked. We're going to hook on a hydrogen, another hydrogen, another hydrogen, and another hydrogen. And that's the 4 hydrogens that we would predict we would need, and 1 carbon. To make the hot diagram, we put down the same element symbols as we had over here, carbon with the 4 hydrogens, and then each single bond is a pair of electrons, 1 from the hydrogen and 1 from the carbon. And then this next single bond is a pair of electrons, 1 from the hydrogen, 1 from the carbon. Okay, and there's 1 from the carbon, 1 from the carbon. So now look what we have around the carbon. We have 8 electrons around the carbon, and each hydrogen has 2. Which, remember, the first energy level is filled when it has 2 electrons. So everybody has full energy levels by sharing. And I put these in black and blue again so that you can see that they are sharing. One of them is from the hydrogen, and the other one of them is from the carbon. So this is a pair of electrons that 2 atoms are sharing. There's this carbon and this atom are sharing those pairs. And our formula is CH4. There's 1 C and 4 H's. And then the name of the compound is we don't do anything to the name of the first element, so it's carbon. And then we see this 4 here, so there's a tetra. And then it's hydride because we put IDE on the end of the second element. Okay, and we're going to pick up here next time we meet. Okay, so today I also wanted to go over some of the homework to help you make sure that you're on track. Okay, so first thing we need to do is look at the periodic table and find that hydrogen is in family 1. It has 1 valence electron. It has an oxidation number of 1, so it needs to make 1 bond. And this is going to be a diatomic molecule. So we're going to need these 2 hydrogens are identical. Okay, for both in family 1, they both have 1 valence electron. They both need to make 1 bond. Since this is diatomic, we know that we're only going to need 2 atoms. We're going to need 1 of each, 1, 2 atoms. Okay. Start off over here. The other hydrogen gets 1 dot. Okay. And then I said to throw away the unused pieces. So we're going to get rid of these pieces. And these extra electrons we don't need. Leave them up there. We also have an option of using up to 8. Okay. And it says to drop in our line drawing. So we're going to drop in this hydrogen. Drop in this hydrogen. We can see our single bond here. We see our single bond here. We know that that's how they're going to hook together. Now, each hydrogen is supposed to have one electron. So one blue one, that's all we need. So we can throw the rest of these in the trash. We're only going to single bond, so we don't need this triple bond. We don't need this, and we can dump the rest of these in the trash too. In our formula, we have hydrogens. We have 2 of them. So when we go to name it, it's di because of the 2, and we don't change the name of the first element, so it's hydrogen. You know, that looks good. Okay. Now we're going to take a look at the second one. It says we want to bond hydrogen to chlorine. We know hydrogen is in family 1. It has 1 valence electron, and its oxidation number is 1, so it needs to make 1 bond. Chlorine is in family 7, it has 7 valence electrons, and its oxidation number is 1, so it needs to make 1 bond or share 1 electron to get to a total of 8. Now we're going to circle the smallest number of bonds, okay? And the smallest number is 1, so we know that the hydrogen is going to single bond, and so is the chlorine. So since they're both going to single bond to each other, we're going to need 1 of each. So we're going to have 1 hydrogen bonded to 1 chlorine with this single bond, which means that they're going to single bond together here. Now, the dot diagram for hydrogen should have 1 dot. And the dot diagram for chlorine, because it's in family 7 and it has 7 electrons, it should have 7 dots in its dot diagram. And trash this one. Get rid of the rest of these electrons that we didn't need. Now, we got to check these pieces up here. The hydrogen is supposed to have 1 valence electron, and there it is. It's the one that is shared. So the hydrogen doesn't need any of these extra electrons. So we can trash these. We didn't use a double bond. We didn't use a triple bond, so we can trash those. Now we check up here. Chlorine should have 7 valence electrons. There's only 1 here, so we need to add the other 7. So we got 1, 2, 3, 4, 5, 6, and 7. And now look, we have 8 electrons around the chlorine. That's a full energy level, because it counts the ones it's sharing as well. So it's 2, 4, 6, 8. And the hydrogen counts the ones that are being shared too. So it has a full energy level on that first energy level of 2. So our formula is going to be HCl. That's going to be hydrogen or our we're going to bond an oxygen to an oxygen. We know oxygen is in family 6, has 6 valence electrons. Its oxidation number is 2, so it needs to make 2 bonds. We also know that this is diatomic. Okay, so it's 6, 6, 2. And since it's diatomic, we need 2 atoms total, so we need 1 of each. So one of these and one of those is 2. You know this is diatomic, so we could really put in the formula now. We know it's diatomic, it's going to be O2. Okay. Now the dot diagram for oxygens, it has 6 dots for its 6 valence electrons. We can get rid of these 2 extras. Okay, and then the other oxygen should have 6 dots in this dot diagram. And we can trash these other 2. Okay. Now we're going to circle the smallest number of bonds, and we know that the oxygen then should double bond. Since they're both 2, they're going to be making this kind of a bond. So our oxygen is going to double bond, and it's going to double bond to the other oxygen. We said that this double bond equals 2 pairs of electrons. So this is how our bond is going to be. Okay, it's a double bond, 2 pairs of electrons. So we don't need this single bond, and we don't need the triple bond. We look up here. Oxygen is supposed to have 2, 4, 6 electrons. Right now there's only 2 right here. So we need 2, 3, 4, 5, and 6. We can trash these other ones. And then this one should have 6 also. It's like this is supposed to have 6, but there's only 2 blue dots here. So we need 3, 4, 5, 6. We can put the rest of these in the trash. Okay, and then there's 2 oxygens, so we're going to have the prefix di. Since there's only 1 element, we don't need to change the name of anything, so it's just dioxygen. Okay, and that completes our review of this homework.